Hello everyone. I am Divya Sri from the Department of Artificial Intelligence and Data Science. Today, I am going to present my project on customer segmentation using machine learning. Now, without any further delay, let us get into our topic. Customer segmentation is an unsupervised machine learning technique where the main goal is to group customers based on similar characteristics without using predefined labels. Unlike supervised learning, where we already know the output, here the model itself discovers patterns hidden in the data. In this project, we use the Mall Customers dataset, which contains features such as customer ID, gender, age, annual income, and spending score. Among these, annual income and spending score are the most important features because they directly represent a customer's purchasing behavior and financial capability. The main objective of this project is to identify different categories of customers so that businesses can design targeted marketing strategies. For example, high-income customers with high spending scores can be targeted with premium products, while low-spending customers can be attracted using discounts and offers. This helps companies increase revenue and improve customer satisfaction. Now, let us understand the workflow of this project step by step. The first step is data pre-processing. In this step, we load the dataset and display a preview to understand its structure. We also check the data types of each column to ensure that the data is clean and usable. Then, we select only the relevant features, which are annual income and spending score, because clustering works best when we focus on meaningful numerical attributes. The next step is feature scaling. Since k-means clustering is a distance-based algorithm, it is very important to scale the data. If we do not scale the data, features with larger values may dominate the results. Therefore, we use standard scaler to normalize the data so that all features contribute equally to the clustering process. After scaling, we move to one of the most important steps, which is determining the optimal number of clusters. For this, we use the elbow method. In this method, we calculate the within-cluster sum of squares, also known as WCSS, for different values of k, usually from 1 to 10. WCSS measures how compact the clusters are. As the number of clusters increases, WCSS decreases. However, after a certain point, the improvement becomes minimal. This point is called the elbow point, and it represents the optimal number of clusters. In our project, we observe this elbow point and choose the best value of k accordingly. Next, we apply the k-means clustering algorithm. The algorithm works in an iterative manner. First, it randomly initializes cluster centroids. Then, it assigns each data point to the nearest centroid using Euclidean distance. After that, it recalculates the centroids based on the mean of the assigned points. This process continues until the centroids no longer change significantly, which is called convergence. Once the model is trained, each customer is assigned to a specific cluster. These clusters represent different customer segments. For example, one cluster may represent high-income and high-spending customers, while another may represent low-income and low-spending customers. To better understand the results, we visualize the clusters using a scatter plot. In this graph, each point represents a customer, and different colors represent different clusters. We also plot the centroids, which are shown as larger markers, to indicate the center of each cluster. This visualization helps us clearly see how customers are grouped based on their behavior. After visualization, we perform cluster analysis. In this step, we calculate the average values of features for each cluster using group-by operations. This helps us interpret the characteristics of each segment. For instance, we can identify which group has the highest income, which group spends the most, and which group needs more attention from the business. This project has strong real-world applications. Companies like Amazon, Flipkart, and Netflix use similar techniques to understand customer preferences and recommend products. Banks use customer segmentation to offer personalized financial services, and marketing teams use it to run targeted campaigns. Now, let us briefly talk about the advantages of this approach. First, it helps in better decision-making by converting raw data into meaningful insights. Second, it improves customer satisfaction by providing personalized experiences. Third, it increases business profitability by targeting the right audience. However, there are also some challenges. Choosing the correct number of clusters is critical. Also, K-means assumes that clusters are spherical in shape, which may not always be true. Additionally, proper data preprocessing is very important to get accurate results. In conclusion, this project demonstrates how unsupervised machine learning can be used to discover hidden patterns in customer data. By applying K-means clustering, we can effectively segment customers and provide valuable insights for business growth and strategy. This project not only strengthens our understanding of machine learning concepts, but also shows how these techniques can be applied in real-world scenarios. Thank you for your time and attention.